Alright, so let's take a look at today's lesson. We're going to be talking about graphing inverse trig functions. We worked quite a bit on basically the particulars of inverse trig functions last time. We looked at principal values, what that means, why they have to be restricted to be a function. We talked about that last time. What we're going to be doing today is actually graphing them. We're going to be graphing just these three, the arc sine, arc cosine, and arc tangent. We're not going to graph their reciprocals, just them. So let's take a look. We'll look at them one at a time. So let's look at the inverse sine function first and recall the restricted domain and range. Again, it's restricted so that it can be a function. So I'm going to start with just sine values, the principal value, just regular sine values, and then we're going to switch to our arc sine values so that we can really see how the graphs are created. So let's first start with sine. We know this restriction right here, so for my x values for just a regular old sine, I'm going to start with negative pi over 2. Remember, because x's and y's are switched with the inverses, negative pi over 2, 0, pi over 2. We know that sine at negative pi over 2 is negative 1. We know sine at 0 is 0, and sine at pi over 2 is 1. So that's just plain old sine values. We really just need 3 values to graph arc sine and arc cosine, really. So I'm going to take these values, we're going to convert them to arc sine values, and basically we just switch the x and the y. So all we're doing is we're just reversing them. So my x values now are negative 1, 0, 1, and my y values are negative pi over 2, 0, and pi over 2. So these are the parent points of arc sine that it's going to be important for us to know. If you can't memorize them, or that seems like too daunting of a task, then just know the regular sine values and just reverse them. Just switch the x's and the y's. So let's see which one of these graphs is arc sine. So we know we have the point 0, 0 right here. Let's see, this one has a 0, 0 and this one does. Okay, this one doesn't, so that's definitely not arc sine. Let's see, we know we have 1 pi over 2. So pi over 2 is around 1.6. Around 1.6. So we'll just put a little, that's around 1.6. Alright, so if we go 1, 1.6, and then negative 1, negative 1.6. So this one is our arc sine. This is the arc. That is the parent arc sine graph. I want you to kind of take note of its shape, because it's just like a little tiny thing, right? There are no arrows on this. No arrows. I was asked that question earlier. There's no arrows. Why? Because we have a restricted domain and range. We have to stop. We can't continue on. It's just that little tiny thing. Notice how in the bottom part of the graph, it's concave down. See how it's kind of curved down? And in the top of the graph, it's concave up. So that's going to help us with the shape when we draw, because we're just going to get these 3 points. We're like, well, how am I going to connect those together? Well, keep in mind the down part, the lower part of the graph is concave down, and the upper part is concave up. Hopefully that'll help you with the shape of the graph. Alright, are we okay with arc sine? Alright, now let's move to arc cosine. So we're really looking at its restrictions. So I'm going to draw cosine, just regular old cosine. Alright, so look, our y values for the arc cosine go from 0 to pi. That means our x values for the regular cosine, so 0, pi over 2, and pi. We know cosine at 0 is 1. We know cosine at pi over 2 is 0. And we know cosine at pi is negative 1. Alright, those are the cosine values. Now let's do the arc cosine, where again it's an inverse. We're just switching the x and the y values. So let's switch those x and y values. And now these are the parent points for arc cosine. These are the ones that are going to be important to us when we are doing transformations of the arc functions. Alright, so let's go and see which graph that is. We have a point at 1, 0. Okay, 1, 0. We have a point at 0 pi over 2. So pi over 2 we said is about 1.6, so that puts us about right there. And negative 1 pi. So this one is definitely arc cosine. Notice again, it's just 3 little points and they stop. The bottom part of the graph is concave down. See how that's curved down? And the upper part of the graph is concave up. See how it's curved up? We've talked about concavity a week or so ago. Hopefully we remember that. All right, so that is our arc cosine graph. Well, we only have one left. We know that's going to be arc tangent, but let's go ahead and work through the points. For arc tangent, really, it is more beneficial to have 5 points because the ends, the beginning and the ending points are just the asymptotes, right? That's all they are, is the asymptotes, because let's get into it. So just regular old tangent. Regular old tangent. So let's go from, see, here's our restricted range for the inverse tangent function. So for the regular old tangent, we're going to start at negative pi over 2, and then we're going to do negative pi over 4, then 0, then pi over 4, and then pi over 2. We're going to get some extra values in there so that it'll help us determine the direction of the graph. So we know regular old tangent, negative pi over 2 is undefined. At the beginning and end, up negative pi over 2 and pi over 2, he's undefined. We know at 0, tangent is 0. We know at negative pi over 4, it's negative 1. And at pi over 4, it's 1. So now let's reverse them for the arctangent graph. So for arctangent, we're just going to take all those values and we're just going to flip them. The x becomes the y becomes the x. So we're just flipping them. And these are the parent points of arctangent. So let's look at its graph. We know this is arctangent. So at negative pi over 2, which is about negative 1.6, we have an asymptote. We have another asymptote at pi over 2. Then at 0, we have 0, negative 1, negative pi over 4. So for a decimal value, negative pi over 4 is around negative 0.8. Just to kind of help you with decimal values. So we'll just write these on the side. So pi over 2 is around 1.6. And pi over 4 is around 0.8. Just approximately. Good enough for graphing though. Alright, so we look and we see negative 1 would be at about negative 0.8. And 1 would be at about 0.8. And really all these two do for us, these two guys right here, all they really need to do for us is tell us which direction we're going, right? If I didn't have these two, this one and this one, I would just have this. How would I know which way I'm going? I mean, I guess you would know by transformations if you wanted to memorize all that. But really, just if you're looking at points, it's helpful to know which way it's going. It's like it's laid on its side, right? We do have arrows here because it continues on forever and ever. Why? Because the domain is all real numbers. It's like a tangent graph. So we know tangents like this, remember? It's kind of like a tangent graph laid on its side. Right, if you rotate it 90 degrees, not exactly, but I mean if you think about it, rotated 90 degrees, I mean it's not going to have the right shape. What I'm saying, it's basically when my original tangent function has my range from negative infinity to infinity, my inverse function's domain is negative infinity to infinity. Yes. So are we okay with that? All good? Okay. So let's take a look. We have a couple of problems, 3 problems on the next page that we're going to go look at and work. Now, whether this is comforting or not, I don't know, but you're only going to have to deal with 1 to 2 different transformations on these. You're not going to do 4 transformations. Okay, so that's it. 1 to 2 transformations on the arc functions, on graphing. All right, so let's take a look at the first one. We're asked to find the domain and range and graph arcsine of x minus 2. So I'm going to write the parent points. These are the arcsine points. So we did -1, 0, 1, negative pi over 2, 0, pi over 2. Those were our parent points for our arcsine. Now let's transform the points. Transformations, just like any other functions we've ever used transformations on. If we look at this, we see this is a right to transformation, which affects the x value, right? Right to. There are no y transformations, so my y values are still going to be negative pi over 2, 0, pi over 2. I am adding 2 to each of those x values, so -1 plus 2 is 1, 0 plus 2 is 2, and 1 plus 2 is 3. Okay, those are my transformed points. Now the grids that I'm going to give you I think are a little bit handier than the one that we were looking at, because I've embedded, see the little negative pi or pi over 2 and pi, I've tried to put those in there in multiple locations so that you can kind of get a feel for it a little bit better than doing like 0.8 or 1.6. So let's graph. So we need to go to 1. When x is 1, y is negative pi over 2, be about right there. When x is 2, y is 0. And when x is 3, y is pi over 2. Okay, so we have our 3 points. And we're thinking, okay, now how am I supposed to connect those? Let's think back. So remember the bottom half was concave down. Remember, that's what, so it needs to be like curved down. So I need to curve the bottom part down. And then the top part is concave up. So I need to curve that part up. And there's our graph. There aren't any arrows. Why aren't there any arrows? Because this is very little, just a little bitty tiny thing. It's very restricted so that it can be a function. Now let's do its domain. So domain is from what, 1 to 3, including 1 and 3. Range is from negative pi over 2 to pi over 2, including both negative pi over 2 and pi over 2. Okay, how are we? Now I want to make a note here. Let's say that I did have a transformation that affected the y. Let's say that I did have like a plus 2 on the end here. Okay, I'm just saying what if, because you're going to have some like this on the daily work and on quizzes and tests. What if? This is not a calculator activity. We're not going to actually use a calculator. We would just write, okay, let's just the what if scenario. It's not this problem. Okay, what if I had a plus 2? What if I had a plus 2? Well, my x values would be the same. My plus 2 would be negative pi over 2 plus 2. 0 plus 2 is 2, and pi over 2 plus 2. Do not worry about combining those together. There's no sense. Because if we're doing negative pi over 2 and then adding 2, we would just go to negative pi over 2, and we would go 2 spaces up. Right? That's all. I don't need you to get a decimal approximation. I mean, you're not going to have a calculator, so you wouldn't be able to. So please know that you just leave it like that. And if that would be like the range, right? The range would be negative pi over 2 plus 2 to negative pi, or to pi over 2 plus 2. So a range on a problem like this would be negative pi over 2 plus 2, comma, pi over 2 plus 2. End. Okay, I don't need a decimal approximation there. That was confusing students earlier. My fault. I didn't have any like this on the notes. Are we okay with that? Okay, so you will encounter ones like that. Okay, this is what if. That's not the problem. All right, so now let's move on to arc cosine x plus 3. So let's write down the parent points for arc cosine. So the parent points for arc cosine are 1, 0, negative 1. 0, pi over 2, and pi. Now let's look at the transformed points. Okay, so what's happening? My transformation says I'm going left 3. Right, so I'm going to have to subtract 3 from x. Y values are untouched again. So y values 0, pi over 2, and pi, they aren't touched. So I need to subtract 3. So we do 1 minus 3 would give us a -2. 0 minus 3 gives us a -3. -1 minus 3 is -4. Okay, there's my transformed points. Is everybody okay? So now let's plot those transformed points. So I go to -2, 0. Okay. I go to -3 pi over 2 would be about right here. And I'm going to have to erase my little what if example. Okay, so then I have -4, which is kind of right here, pi. It would take me about right there. Okay, so we have our 3 points. We need to remember, what do? The bottom part is concave down, so it needs to curve down. The upper part is concave up. Okay, let's do our domain and range. So domain, what are we going from? -4 to -2. My range, we're going from 0 to pi. Okay, we okay? Last one is dealing with arctangent. All right, so let's do those parent points. I have 5, just so that I know which way I'm going. So the parent points for our little guy arctangent are undefined, -1, 0, 1, undefined. For x values, -pi over 2, -pi over 4, 0, pi over 4, and pi over 2. Okay, so there's our parent points. So what is happening? What kind of transformation do we have? We have a negative arctangent, which means all of the y values are multiplied by a -1 and nothing happens to the x values. Right? All the y values are multiplied by -1. Nothing happens to the x values. So this is the transformed. So x values stay the same. So that would be pi over 2, pi over 4, 0, -pi over 4, -pi over 2. Now let's say you had another y transformation there. Let's say you had negative arctangent x plus 2. You would do the multiplying one first. You would multiply all the y's by -1, then you would add 2. Okay, so we have to do it in that order or it's not going to work. All right, so let's, our asymptotes are still at pi over 2 and -pi over 2. So let's draw our little horizontal asymptotes. They're still there. We're still at 0, 0. But now we're at -1 pi over 4. -1 pi over 4, about right there. And 1 -pi over 4. Okay, so see how the pi over 4s just kind of tell us which direction we're going? See how I'm up and over to the left? That means that it's coming this way, right? It's going up to the left instead of like it normally does, which is up to the right. So our graph would look like this. This one needs arrows because it continues on forever and ever. So our domain would be -infinity to infinity. Our range would be -pi over 2 to pi over 2, not including those because they're horizontal asymptotes. And that's our arctangent little guy. Are we okay?